My life seemed to be a series of events and accidents. Yet when I look back, I see a pattern. Benoit Mandelbrot. Recursion is an integral part of the modern time in which humanity currently exists. It forecasts our weather, makes our movies, and even allows us to breathe. Yet so few people know what recursion is, and of those that do know what it is, they don't understand it very well. So, in order to alleviate this ambiguity, I've commenced an extensive unbiased research. For the purpose of expounding upon the ideas of fractals and recursion, this presentation will explain the facets of recursion, the aspects of fractals, and the significance of fractals and recursion to human life as it stands currently. So, what is this recursion thing? Recursion is defined by catb.org as recursion. Not exactly the most helpful definition. So, Eric Weisstein of Wolfram MathWorld of Wolfram Alpha defines recursion as a process in which objects are defined in terms of other objects of the same type. So that's a little bit better. So now an analysis of this definition provides that recursion is the repetition of an entity within the same entity. So examples of this would be something like the Sierpinski triangle, which is a triangle within a triangle. And then within the smaller triangle, there are defined triangles, and those defined triangles are then separated into more triangles and more triangles, all the way on to infinity. Another example would be the Drost effect, which is an image contained within that image. And it's the same image within that image. And then within the smaller image, there's the same image again, and again, and again, and again, onto infinity. The third example is fractals. What's a fractal? The UXL Encyclopedia of Science defined fractal in 2002 as a geometric figure that is irregular, fractured, fragmented, or loosely connected in appearance, and is self-similar. That is, the figure looks much the same no matter how far away or how close it is viewed. So, some examples of this are the Mandelbrot set and the Julius set, which are pretty common examples. And then there are also examples in nature, such as Romanesso broccoli, which is a spire that has spires coming out of it, and those spires have spirals all around them. And those spirals are spires that have spirals all around them, all the way on to the limits of matter. Another natural example of a fractal is a coastline on an island, because no matter how far away or how close it is viewed, it still has a similar recurring pattern. So why am I telling you all this stuff? Why am I going through all this trouble to talk about recursion and fractals? Fractals are significant because they are applicable to many common day instances, such as weather forecasting, irregular object measuring, and population growth estimating. ThinkQuest.org defines many examples of the applications of fractals. It provides examples such as movies. Currently in movies, if you ever have a landscape in which anything's going to occur, it is either filmed in the real world or the landscape is defined by a fractal, so that the fractal explains the undulations of the environment. So whether it's a mountainous planet in some far-off galaxy, whether it's a hillside in the country, or even whether it's the Death Star in Star Wars. Another example is data compression. In December of 1992, Encarta Encyclopedia released a compact disc that contained thousands of encyclopedia articles. These thousands of encyclopedia articles contained more than 7,000 photographs, more than 100 animations, and more than 800 color maps, all of which was contained in less than 600 megabytes of data. Additionally, ThinkQuest.org provides lung capacity as an example. Our lungs, based on the naked eye, just observations, can hold between 60 and 80 cubic centimeters of air. Okay? But when viewed under light microscopy, the lungs have an estimated capacity of between 140 and 160 cubic centimeters, thus nearly doubling the estimation for our lung capacity. So, in conclusion, in this presentation I have attempted to explain fractals, recursion, and their significance to human life. So when you look back on your life, as Benoit Mandelbrot did, what will you see? Will you see chaos and disorder and confusion? Or will you see a pattern of sorts?